The last organ that we'll talk about is the pancreas. The pancreas is actually considered a digestive organ, but it has endocrine function. So it has a region known as the islets of Langerhans, or the pancreatic islets, that have endocrine function. And we like to talk about this here. I'll talk about it again in chapter 26 when I talk about the digestive system. So the pancreas has both exocrine and endocrine functions. The exocrine functions are all of the enzymes that are produced in the pancreas that are released into the small intestines to break down proteins and carbs and nucleic acids and fats. Also, some mucus is released from the pancreas to decrease the acidity of the environment of the small intestines, because it's going to be very acidic initially, since we have acidic juices in our stomach. The endocrine functions then occur in the pancreatic islets, and we have different endocrine cells. This is a close-up of the pancreatic islets. And the two major, so there are a lot of different cell types in the pancreatic islets. The two that we talk about are alpha and beta cells. Alpha cells secrete a hormone called glucagon. Beta cells secrete a hormone called insulin. There's also delta cells and F cells, but we don't talk a lot about those cells. So the only two you need to worry about are these alpha and beta cells. So alpha cells produce glucagon, and glucagon is released when our blood glucose levels are really low. And what this does is it causes the cells that are storing up glycogen is a stored form of glucose, to break down the glycogen and release the glucose back into the blood, bringing our blood sugar levels back to normal. So this is a negative feedback activity, and it's also called a catabolic activity since we are breaking something down. The beta cells then are releasing insulin in response to high blood glucose levels. And so insulin is released after we have eaten a meal, and it causes us to take in, our body cells to take in glucose and build up glycogen reserves. So this would be an anabolic activity because we're building something up. But in both cases, we're maintaining blood glucose levels. So glucagon and insulin are antagonistic hormones. Both work in maintaining glucose levels of the blood. This is a negative feedback mechanism. You notice me saying that a lot lately, so negative feedback is super important. It's one of the most common mechanisms of maintaining homeostasis. Negative feedback, you have some variable, and that variable is at some point, and that set point is, here, and you're constantly fluctuating right around that set point, which is normal, and then something brings you away from that set point, and this brings you back. Negative feedback brings you back. Okay? So in this case, here's a figure from your textbook that shows increased glucose in the blood, probably because you had some, extra donut or something, right, at your mealtime. This is going to stimulate the pancreas to produce insulin. Insulin is going to be released from the beta cells, and insulin is going to move into the body, to the body cells, same body cells that respond to glucagon actually, and cause glucose to be taken in and glycogen to be built up. Here we have the opposite. So we have a decrease in blood sugar levels, And again, that stimulates the pancreas, but this time the alpha cells are going to release glucagon. Alpha cells release glucagon, and this stimulates the liver and other tissues to release glucose or release molecules that can produce new glucose. Oh, sorry. So this is another form of negative feedback. Here's a video on the pancreas.
The organs of the endocrine system secrete hormones directly into the bloodstream to assist in the regulation of various body functions. The endocrine gland discussed here is the pancreas. The pancreas is an elongated organ situated between the duodenum of the small intestine and the spleen, inferior and posterior to the stomach. It is both an exocrine and endocrine gland. The pancreas consists primarily of exocrine acinar cells and their associated ducts. Organized in glandular clusters, pancreatic acini secrete enzyme-rich pancreatic juice via the pancreatic ducts into the duodenum to aid chemical digestion. Scattered among the acini are small clusters of endocrine cells known as pancreatic islets, or islets of Langerhans. Each pancreatic islet contains 4 types of cells: alpha, beta, delta, and F cells that release hormones into the bloodstream. When blood glucose levels decline, alpha cells secrete glucagon, a hormone that stimulates the liver to break down stored glycogen and release glucose into the bloodstream. When blood levels of glucose and amino acids rise, such as after a meal, beta cells secrete insulin. Insulin stimulates cells to absorb glucose and amino acids from the blood and to store excess nutrients. Delta cells synthesize somatostatin. This hormone inhibits the release of insulin and glucagon and slows the activities of digestive organs, thereby slowing the entry of nutrients into the bloodstream. F cells secrete pancreatic polypeptide to suppress and regulate somatostatin secretion by delta cells. Together, these pancreatic hormones provide for the orderly uptake and processing of nutrients.
All right, one of the most common disorders that most people associate with the endocrine system and most people know of is called diabetes mellitus. So diabetes mellitus is just the inability to use glucose properly. And because we can't use glucose, we can't take glucose into our cells and use it, we have high blood glucose levels. And these high blood glucose levels can lead to all kinds of problems, including high blood pressure, damage to cells. It can cause retinal blindness. It can lead to renal failure. When cells get damaged and die, they can lead to eventual necessity of amputations because you don't have, well, the cells are dead. So all of this is associated with diabetes. There are a lot of types of diabetes out there, and people get confused. They think diabetes is diabetes. Diabetes mellitus is one form, and this is where glucose is associated with where glucose is associated with the disorder. Type 1 diabetes occurs when the beta cells stop functioning. So it's not so much that we have beta cells functioning, but the receptors for glucose aren't functioning as effectively because they're they're desensitized because there's so much glucose in our system. It's more that the beta cells don't work at all. They just stop making glucose or making insulin, so we don't have any insulin in our system. This is an autoimmune disorder. Type 2 diabetes is not an autoimmune disorder. It's a disorder associated typically with increased glucose or sugar consumption. So when you eat a lot of foods that are high in fats, high in sugar, then eventually your cells become desensitized. And so the amount of insulin in our system, the receptors don't respond to that, and so the glucose stays in our system. That's known as type 2 diabetes. Type 1 diabetes is not a very common form of diabetes. It only affects about 5% of the U.S. population, the population in general. It is a hereditary form, so it is an autoimmune disease and it is genetic. It usually starts when another virus activates the disorder. So you basically get sick with a cold or something, and then that causes your body to produce BNT or activate BNT lymphocyte production. B cells produce antibodies, T cells produce killer T's and memory cells, and then we have these antibodies that start attacking the beta cells. So they attack the pathogen first, but then the pathogen and the beta cells, the antibodies don't recognize a difference there, and so they attack the beta cells, and you no longer have the ability to produce insulin because your beta cells are no longer there. So treatment for this at this point is insulin injections, an insulin pump, and I've never heard of this before, but well, I've never seen it before, I should say. I've heard of it. Insulin inhaler. We also have type 2 diabetes. This is the most common form of diabetes, and this is associated with resistance to insulin. So risk factors: obesity, so having a very poor diet, being obese, not exercising enough, being old. So old, that sounds so sad because 40 is not old. I'm in my 40s and I don't feel old. But typically you don't see type 2 diabetes in children. It is becoming more common because of the rise in obesity, but it's still seen more often in individuals who are over the age of 40 years. Treatment for this can be the same as treatment for type 1 diabetes, but oftentimes we can treat it with just oral medications, exercise, and diet. And this form of diabetes can go away. So it's like, I don't have to have diabetes. I can just fix it by changing my lifestyle. Super awesome. Gestational diabetes is very similar to type 2 diabetes, but in this case, it's not so much that our cells are becoming insensitive to sugar or to insulin on their own. The fetus is releasing hormones that cause our cells to become, or cause insulin to no longer function properly. And because of that, we have higher glucose levels, which allows the fetus to get the nutrients, but also can lead to gestational diabetes. We'll talk more about this in chapter 28. And then we have hypoglycemia. Hypoglycemia is low blood glucose levels. This can be caused by using too much insulin, too long of exercise, if you have deficiencies in cortisol levels. These can all lead to hypoglycemia. Typical treatments are to add nutrients to your diet, take pills, like they have glucose tablets that you can chew on now, and that usually treats the disorder. This is the end of chapter 17. So get ready for your exam. Bye.